All right, welcome. In this explainer, we're going to break down one of the trickiest topics in SPM chemistry, acids and bases. And I promise by the end, you won't just get it, you'll have a real strategy to absolutely ace your exam questions. But first things first, the real key to mastering any topic isn't just about watching a video. It's about active learning. You've got to put what you know to the test. And that, my friends, is where MCQ SPM is a total game changer. It's an incredible platform just packed with thousands of past year questions. It lets you actually test yourself and see where you stand. So go on, scan the QR code right now, or just look up the app on the Google Play Store. Get it ready, because you're going to want to practice what you're about to learn. Okay, let's dive into the juicy stuff. If you want to score well in this chapter, you need a rock-solid foundation. And believe it or not, it all boils down to two tiny, super powerful particles. So what really gives an acid its power? I mean, you might think it's the sour taste or something like that, but its true strength comes from something happening at the molecular level. And here's the catch. It only happens under one very, very specific condition. And this is the part you absolutely cannot forget. An acid must be in water to show its properties. A molecule like HCl on its own is just a gas, but when it dissolves in water, it releases its powerful hydrogen ions, H+, and that process, ionization, is what gives it all its acidic powers, like turning blue litmus paper red. So remember the rule: no water, no H+, no acid. Simple as that. And guess what? It is the exact same logic for alkalis. An alkali's power comes from releasing these things, hydroxide ions, OH-, when they're in water. These little guys are responsible for everything we think of as alkaline, that soapy feel, turning red litmus paper blue, the whole shebang. Okay, now that we've got the foundation totally locked in, let's look at the fun part, where students often lose marks. We're talking about those classic exam traps that look so simple but are designed to catch you out. Take a look at this. It's a classic exam question. The answer, by the way, is ammonia. Now, a ton of students get this wrong. But why? What on earth makes ammonia so tricky? Here is the trap. You learn about strong alkalis like sodium hydroxide, and your brain starts to create a shortcut. It thinks, oh, an alkali must have hydroxide in its name. And boom, that's the mistake. You're forgetting the fundamental definition we just talked about. So here's the secret. Ammonia gas, all by itself, isn't alkaline. But when it dissolves in water, something really cool happens. It actually reacts with the water molecules. It kind of steals a hydrogen ion from H2O. And what does that leave behind? Well, it releases those all-important hydroxide ions, OH-, and that's what makes the whole solution alkaline. And it doesn't stop there. Here's another one, this time testing your acid knowledge. The correct answer here is carbon dioxide. And yep, you guessed it, this one trips up a lot of students too. The trap here is thinking that acids have to be liquids. But remember our number one rule? It's not about the state of matter at all. It's about what happens when that substance gets together with water. Now, what's really interesting about this is that these traps, they aren't random, not at all. They're actually part of a very clear pattern that examiners use year after year. And this table just illustrates that pattern perfectly. Examiners love, and I mean love, to test these specific gases, ammonia, carbon dioxide, and sulfur dioxide. Why? Because they force you to apply the core definition instead of just memorizing a list. They all react with water to make those key H+ or OH- ions. If you can master these three, you've pretty much cracked a key exam pattern. So how do you tackle any question on this topic with total confidence? Let's build a simple, foolproof three-step game plan. Look, no matter how complicated the question seems, you always come back to these three simple steps. 1, identify the substance. 2, and this is the most important one, ask, is water present? And 3, target the ions. Are we looking for H+ or OH-? I'm telling you, this framework will never let you down. Let's look at a perfect example of why this strategy just works. This comparison shows you exactly why step 2, asking if water is present, is so incredibly critical. Without water, hydrogen chloride is just a gas. No free ions, no acidic properties, nothing. But you add water, and it completely transforms into hydrochloric acid, unleashing those H+ ions and its full acidic power. So let's wrap this up By really mastering the core definitions, spotting those common exam patterns, and just consistently applying our 3-step strategy, you can turn even the trickiest questions into easy marks. You're totally equipped to handle this topic now. Okay, now it's your turn. It's time to put it all into practice. Head over to MCQ SPM and test out your new strategy on hundreds of questions, just like the ones we've covered today. That's how you turn understanding into real exam success. Happy revising!